This first chapter is a little vocab heavy. This is 1-1, which is points, lines, and planes. So, of course, we're talking about three things, points, lines, and planes, right? These three things are called undefined terms. What we mean by undefined is that you can only explain these three things using examples and descriptions. Like, this is what it looks like. There's not a true definition as this is what a point is. This is what and we tell you that by giving you a figure, right? So a point's a location, and we obviously probably all know what a point looks like. You know, there's a point, okay? Now, points have no true size, okay? You can't measure a point. Even though when we draw it, like this looks like a bigger point, and then this, they're both points. We don't have big points and small points. We don't have 1 foot points and 1 inch points. Okay? A point's simply a location on a line, on a plane, in space, somewhere like that. Okay? So there are three undefined terms. Again, these three terms are points, lines, and planes. Okay? These are the three undefined terms that we talk about. We can only define them by using figures, by using examples. Okay? A point, there's the figure, there's the example. Okay? That's what an undefined term is. Again, pretty vocab heavy, but let's go through each of these. Not every chapter is like this, I promise. Okay? But a line, okay? A line's made up of points, it has no thickness or width. Okay? Line made up of points, has no thickness or width. With a line, we always put arrows on the end of it. The reason we do that, why do you think the reason we do that is? It goes on forever, right? You can't measure a line. It goes on forever, okay? So this is the figure of what a line would look like, okay? Co-linear, okay? Co, like a co-op. The co means that you share something, right? So co-linear, linear means line. Co-linear talks about points that are on the same line. So if I give you a figure and ask which of these points are co-linear, you would give me the points that are on the same line. They share the same line, okay? A plane, it's a flat surface. It's made up of points, has no depth, so it's not like a pool, right? It has no depth, and it extends infinitely in all directions. Okay? We usually draw it as like a slanted figure like that, but it technically goes on in all directions. Okay? So like the ceiling would be a plane, but it's cut off at each of the four walls, right? The floor would be a plane, but it's cut off at each of the four walls. But a plane goes on forever, and it's made up of lines and points, but it has no thickness, okay? It's just a flat surface when you're looking at it. We usually draw it like this, even though technically it goes on forever in all directions. Okay? Coplanar are points that are on the same plane. Co means share, planar means plane. So if I ask you which of these points are coplanar, they share the same plane. Last two, space. Space is what we talk about in geometry where we put the figures, okay? It's boundless. It has no bounds. It's a three-dimensional set of all points, lines, and planes. So we just talk about we put points, we put lines, we put planes in this space, okay? Just a three-dimensional area. We just put it in space. Pretty much all this section is just naming points, lines, and planes. Okay? How do we name them? How do we draw them? What do they look like? But this is just how we represent these things. Again, I wouldn't worry about drawing this out. But a point, we represent it as a dot. Okay? It's always named by a capital letter, so this is point P, obviously. And again, it has no size or shape. You can't measure points. Point's just a location on a line. Okay? It's where it's at. Point P is how we call it. A line, we always have arrows on the end. Okay, because it goes on forever. Now there's two ways that you can name a line. You can either name it with two of the points and then a line on top, so like line AB, line BA, okay? Or you can put the word in front of it. Most people would put the two letters in the line on top. That makes sense? It's always with 2 points. It's never with 3. So for example, if I had a point here and this was C, you can name it line AC, CB, AB, BA, BC, whatever you want. It doesn't matter the order. You just always pick 2 points, and then most people usually draw it with a line on top of it. And you put both arrows on these. Okay? You could also name it, sometimes with lines, there's a little lowercase letter that's cursive, or not cursive, italicized, referring to line. You could also call it line N and put N or line in front of it. So you can either write the word line or you can just draw the little bar on top of it. And then we have a plane, okay? A plane is named with 3 points in it, but it doesn't matter the order. So this is all referring to the same thing. This is plane XYZ, ZYX, whatever order you want. Or the same thing, it might have an italics letter in the corner. You could name it plane T also. And you just always put the word plane in front of it. There's no drawing with it. There's no figure. Okay? So all I'm doing in this section is giving you a figure and telling Nate, what's this line called? What's this plane called? What's this point called? Use 1 point, use 2 points, use 3 points. Okay? So, use the figure to name a line containing point K. So what would be one example of a name that I could give the line that contains point K? I want to name the line that contains point K. There's a bunch of different answers to this. One would be, well, the B technically is referring to the plane because it's a capital letter in the corner. I could call it line A because that's the italicized. What are other answers? Yeah, what?
Line JL.
Yep, I could name it
Or
JL. I could name it JK. I could switch those around. I could name it KL. I could name it LK. And there's a few more, right? They're all referring to the same line. The key is you always pick 2 points and you put a line above it, or you use the lowercase letter and write line in front of it. And that's how we name a line. Always with 2 points and you put the line above it. You wouldn't call it line KM though, right? Because there's no line there. Or line LN. Or you wouldn't call B because B is referring to the plane. Okay. So there's a few different answers there. Name a plane that contains point L. So what would be one way that I could name the plane? Well, the capital letter in the corner, I can name it plane B. And again, if we go back here, oops. When you name a plane, I think I forgot to mention this, it has to be 3 non-collinear points. Non-collinear means they don't share the same line. So here, you have to pick 3 non-collinear points to name this plane. So you could, again, say plane B. You could also say what? JML. You could say plane KML. And there's a bunch of others. You just could not say plane JKL. That would not work because those 3 lines, those 3 points are collinear. Okay. When you name a plane, you either do it by the capital letter in the corner or you do it with 3 non-collinear points. They can't be on the same line. Okay. Name a plane. When you name a plane. Okay. JKM, KLM, JLM, or any order of those. Use the figure to name a line that contains point X. What are some names of this line that has point X on it? Yeah.
C.
You can name it line C. What else could you name it?
XQ.
XQ. What else could you name it? XY, QY, YX, YQ, right? There's a bunch of different possibilities. It's either with the lowercase letter or 2 points. Okay. Name a plane. It's an example you could use a plane. Plane P. What else could you call it?
YZX.
Plane YZX, QZY, XYZ, right? You just could not call it plane XQY because those all share a line. Okay. So, some of the book questions ask you this. Name the geometric shape modeled by a water glass on a table. So you know, here's my good sketches. A water glass on a table. That would be like a point on a plane, right? That's what it would be modeling. technically, I mean, a plane though extends forever in infinite directions, right? But we can't draw that. But the model for this, a water glass on a table would be like a point on a plane. Okay. Name a geometric shape modeled by a colored dot on a map. Again, that would be a point on a plane. Name the geometric shape modeled by the ceiling of your classroom. That would be best represented as a point, line, plane, or none. Plane, right? Okay. Name the geometric shape modeled by the rail of a stairway. That'd be like a point, line, or plane. Probably best like a line, right? The difference between a line and a line segment, I think I'll come to this in just a second, is a line goes on forever in both directions. So for example, that's line, or we can call it line AB. A line segment, so a segment means a piece of, right? It would be like, this would be line segment CD. It has two endpoints. It could actually be measured, okay? A line segment can be measured, a line cannot. A line is infinite, a line segment is just a piece. It has two endpoints, okay? And with that, we would just put a bar over the top. We don't put the arrows on the end because it's just a segment of it. It's just a piece of it. Draw this figure. So draw and label a figure for the situation. You have plane R. They already gave us that. I want lines AB and lines DE that intersect at point P. And you want C on plane R so that it's not collinear with those two lines. So let's just take it one step at a time here. Plane R. I want it to have AB and DE in there. So for example, I could not do this. In this figure, I want it to contain that. So anywhere I want, I can draw a line and call it AB. I also want DE to intersect at point P. So I want another line that I call DE, and I want to intersect at point P. Finally, add another point C that's on this plane, but it's not collinear with these. So there's a bunch of different ways you could put it. But for example, if I put it right there, it's not collinear, right? It doesn't share any of the same lines. That makes sense? So that's just drawing out the figure if it gives you a situation. Lines always have arrows on the end. Intersection point, not collinear, plane R. Okay. I know this stuff's kind of dry, but this is how we get stuff, how we name stuff to start with. Another example there. Okay. Draw and label this figure. This would be very similar. You have line QR. It contains the point -2, 4, and point 4, -4. Add point T so that T is collinear with these points. Collinear means what again? Shares the same line. You could add point T there, 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 wherever you want. It would be collinear, right? Definition of collinear, it's on the same line. Looking at this figure, choose the best diagram. I want plane D. It has those three lines. They all intersect at point Z. And also I want point F that's not collinear. So if we called this, which of these best represent that figure? Yeah, I would say B, right? The reason this wouldn't, because F's collinear. It says it's not collinear with any of the lines. What about the reason this one wouldn't?
There's no A.
Line A in this case, okay, is not contained in the plane, right? Remember we said planes have no thickness? It goes through the plane, but it's not contained in the plane, right? So that would be why that one's not. This one would be because, again, point F is collinear. The correct answer would be B. Yeah. That one's the exact same. We'll jump through that. Another question here, how many planes appear in this figure? This is a little bit of a trick question. We know there's at least one, it would be this one, right? There happens to be another one though, okay? The other plane would be this one. Those three non-collinear points together make up a plane. So there would be two planes in this figure. This one and plane S. Okay. Name 3 points that are collinear. There are only 3 points. What are they? A, B, and D. Collinear share the same line, okay? At what point do lines DB and CA intersect? What's the point that they intersect? A, right? That's where they cross, intersect, okay? Not too difficult. How many planes are in this figure? Again, we just talked about that. It's going to be 1, 2. Name 3 points that are collinear. There's a couple different options. We have one here, those three, or those three. They're all collinear. They all share the same line. We're starting to see how this works now. Here's a question. Are X, O, and R coplanar? Are X, O, and R coplanar? Co means share, planar means plane. Do X, O, and R share the same plane? Yeah, they're all in that plane T, right? They are coplanar. Okay. This was, at what point do BN and XO intersect? So line BN would be this one. Line XO would be this one. At what point do they intersect? We would just say point R. Okay. Pretty straightforward. All right, let's go to our first construction here.